Okay. Well, hello, everyone. As Courtney said, I'm Bruce McLaren from Carnegie Mellon University. Thanks for that nice introduction, Courtney. And I should mention that well, I'm going to introduce myself. I'm an instructor in the metals program, and Courtney was actually in that metals program, so she was a student of mine at one point. Okay, so a little bit about who I am. Again, I'm a professor in HCI, Human Computer Interaction at Carnegie Mellon. And I'm an instructor of CMU's Metals Capstone course. And what that course is about, it's a master's program, and teams of students work together with the instructors and a mentor, and they actually develop a real world product for clients that we get to work with them. So I've been doing that for about 10 years. So lots of different projects have gone by me, and I think I've not only have guided the teams, but I've learned a lot from the teams that have developed these products. And I'll talk about a few of those at the end of the talk. I'm also a researcher, a scientist. I'm the head of what I call the McLaren Lab, and that's not a misspelling. It's a play on my name, McLaren Lab. And I do research with digital learning games, tutoring systems, and collaborative learning systems. And the other thing that I can bring to bear and give you some input on is before becoming a professor, I spent around 15 years as an engineer and consultant for a software company. That work was not focused specifically on education, but it was in software, and I did do consulting, similar to the kinds of projects that I now lead in the metals program. So that's a little bit about who I am to give you some background on me. And so what I'd like to do today is, here's the outline. I'd like to talk a little bit about the EdTech marketplace, planning, organizing, and managing products and projects. A little bit about applying learning science to educational technology, what some of the approaches that we promote for designing and developing products. And then I'm going to talk through some examples of ed tech companies and projects that I have either been involved with or have knowledge of to give you a little more insight. And all of these projects are associated with Carnegie Mellon in one way or another. So hopefully they'll be, instructive for all of you. I should say that some of these slides were derived from the metals class. And so I may be talking about some things. I know that most of the audience are you're entrepreneurs. Some of this may be information you already know. So I may be covering things that you're already aware of and that you're already doing. But bear with me. Hopefully there'll be some things for you to learn in any case. Okay, so I'm going to start talking just a little bit about the EdTech marketplace, which hopefully many of you are already aware of. So basically, education is a big business, a multi-billion dollar enterprise. And educational technology is a huge piece of that and growing larger by the year. So it's becoming a really big part of the enterprise. Okay. And there are many key players in this space. You probably recognize most of these names, but these are all people who are companies that are involved in ed tech that might not be their sole business, but they're involved in ed tech. And one way to think of the ed tech marketplace. So again, what I was saying on this slide is there's no perfect way to divide up market segments of the educational area. But one way to look at it is I think these four areas are kind of the ones that we are most established. One is K-12, so school age children from ages 6 to about 17 or 18. Higher ed, which is of course university level education. Commercial education, so workplace training, for instance, and then government training. So those are all different segments of the ed tech area. And it can be further broken down by large, medium, and small. So you might have, just very niche areas at the small end to super large companies on the large end. And some of the technologies that you see in ed tech, I mean, of course, textbooks, people don't think of that as a technology, but in fact, It is seen as a technology. Goes back for quite a long time. There's platform providers, tutoring systems, online courses, educational games, MOOCs. All of these are different technologies in the EdTech space. So again, bear with me. I know there are probably some of the things I'm saying here that you're already aware of, but I'm trying to reach sort of the broadest audience here, so I'm going to give some background too. So what I'd like to do now is to talk a little bit about how we teach our students and how we guide teams to plan, organize, and manage projects in the EdTech space. So one of the things that's super important is to do competitive analyses, so to know where your idea fits in the bigger picture and how you bring value that maybe is not already in the marketplace. So when you do a competitive analysis, it's helping you understand how your product could make money while being situated in the right segment of the market. Why perform a competitive analysis? Well, for one, it helps you to benchmark where you are or where you think your product idea is in the larger marketplace. It avoids you duplicating other products. It helps you learn what the conventional wisdom is of a particular market area. Maybe you'll find features in other products that are be worth emulating. In fact, sometimes you really have to emulate some features in order to even be a player in certain market segments. And you can also learn from others' mistakes. So competitive analysis should also include organizations that have not been successful, and you can learn from why they were not successful. It also just generally illuminates the overall problem space that your product is going to be in. And you can figure out here it says clients, but what your customers are talking about. So if you're getting your ideas from asks from customers, it helps you figure out where those ideas fit in the larger picture. So those are some of the reasons to perform a competitive analysis. And there are different aspects of doing a competitive analysis. On one hand, you can do a product competitive analysis. So what are the features of systems in this space? How does the particular system address the specific features? What does it cost? Of course, that's really important. Cost can, range pretty widely in certain market segments. What makes this product unique as you look at other products? What makes that product interesting? Why is it being successful or not? And how is it built? So technology could be important too. It's not the most important thing, but if somebody's building on a technology that's becoming outdated or already is outdated, that could be a red flag. And maybe the makers of that product should be thinking about porting to a new technology. So those are some of the things that you look at with respect to the product. With respect to customers, source and strategy, you think about and look at who are they targeting? Who's their audience? Who are their users? What's the history of the product? What makes this company a threat, or what advantages does this company have in this market? And how do they make their money? So it could be, they sell the product outright. They could have a subscription. That's becoming, of course, more the norm now, having a subscription license. Well, what's the way that they go about making their money? So those are all things that you should be looking at in this with respect to customer source and strategy. The other thing about performing a competitive analysis is, of course, it helps you to identify who the potential competitors are, who are the ones that are closest to the product that you're coming up with, who are the leaders in that area, and what are their both strategic advantages and weaknesses. And where do you want to be in that space? So you want to basically figure out how your features overlap the features of existing products. And often what's done when you do a competitive analysis is you create a matrix of product features. which you then sort of identify which of the features in that matrix are the ones that you're targeting with your product, and which features do all the other products have. So it's a really great way to sort of summarize in one place sort of the feature space, where the competitors lie in that feature space, and where you might end up. So now I'm going to switch to another aspect of the projects and some suggestions that I have for project development. And this is what we do in the metals program. And I think in general it's good in industry to have these 5 different roles on a team. We always strive to have complementary characteristics and complementary skills on our teams. We assign, when we run the capstone, we assign students to teams and to clients, and we do that by picking them to be complementary along the lines of what we think their skills are going to be best targeted at. So for instance, you always have a project manager who's responsible for the process of the team, for leading the day-to-day management, setting the schedule. If you're working for a client, then they're usually the interface to the client. Then there's somebody who's responsible for the overall product management, and that's for heading up the design and development, coordinating team members regarding that prototype. Because we're in the learning science space, this wouldn't always be the case, I think, in all technology developments, but learning science really guides a lot of product development in the EdTech space. So it's really good to have somebody who has sort of a research mind and is willing to look at both what's going on in the academic world, but also to research. And usually that's the person who would perform the competitive analysis, for instance. But somebody who can take the lead in researching for the team. And then there's a design lead, somebody who is responsible for designing the interface, designing related aspects of the product. And then finally, at least one person who's a development lead on the project. So a little bit about working with customers and clients. It's not always an easy thing to do. Frustration, sometimes conflict will come from that. You need to understand what your customers' and clients' agendas are, and you should address those issues early. And it's really important. Here's a nice quote from Mark Nuttall, the principal of IDEO, and talking about the importance of partnerships. So when you're developing a product for a particular organization, partnership's really important. These are maybe things that you would already know, but again, as I said, I've drawn a lot of these slides from what we present to our metal students, and these are important aspects of running projects and dealing with customers and clients. And at a certain level, professionalism is important, respect for the customer or client, having communication that's very honest and open is also important, and being staying on time with deliverables and being responsible about deliverables is also a really important aspect. You should, of course, have a project or business plan. Again, I'm thinking that many of you who are entrepreneurs already have know about this, but you should have something that's a good guide for your business and technology development. And this confirms that you've listened carefully to what's what you've heard about the market that you're going to be in. And it gives your team an opportunity, a team that's working with you, an opportunity to understand really what the context is of your project. And it provides a detailed plan of what you'll do to execute. So you really should have this. We always tell our students that this is like a living document. So it's not something that you set the plan and then you stick to it no matter what. You should be dynamic and be willing and able to pivot if you need to. Especially, I'll talk a little bit in a while about lean development. and about developing MVPs. And really in that space, you need to be very agile and be able to pivot quickly to changes in the situation. So this plan is not meant to be something that you stick to, despite all that's going on around you. You need to be able to be reactive. So some other elements, we have something that we call the hunt statement. That's sort of like a project statement or a goal statement of what your project's going to be about. It should line up and tell what the team's responsibilities are. I talked about those 5 roles. What you'd want to do is you'd want to make sure that your team, everybody knows what their roles are. We always advocate, especially on small teams, that you have a role, but that's not the only thing you do, that you should be able to participate and support projects and the product development across different roles. So if somebody needs some help, let's say in design or development, and you have some skills in that area, but you're the project manager, there's no reason why you shouldn't be able to support in that area. If you're doing consulting, you also want to state what the client's responsibilities are. And this should also have a schedule, estimated costs for everything, and then a sign off. Okay, so that's a little bit about sort of the product management, project management. Hopefully a lot of you are already aware of many of the things that I've just spoken about. In this particular space, we're, of course, talking about educational technology. And what's really important for educational technology is to bring whatever we know about learning science to bear to your educational technology. So these are just some of the approaches and techniques that we advocate and teach our students in our Metals program. And these are all useful in different ways. So for instance, some of the techniques are designed to collect information and initial data. So techniques such as think alouds, where you have somebody take on a task and speak out loud about what they're doing so you can learn about the task. You could have focus groups. That's where you have a group of people that get together and you get who are knowledgeable in an area, and you pull them and you have discussions about what it is that they do to learn more about it. Wizard of Oz studies are really an interesting area, a technique that's used in HCI and in learning science. And that's where you sort of mock up a technology, and especially if this was done through it's computer mediated, you might have somebody on the other end who's providing responses to a task that someone's been given, and they sort of act like they're a system. And the idea is that you're sort of emulating what a system looks like so that you can learn about what would happen in an actual system. So that's another approach. But all of these approaches that you see here on the screen are ones that our students apply. Hopefully you're familiar with at least some of these approaches. One like affinity diagramming, that's a technique that once you've collected data, you use that to organize. So you have sort of like pieces of data that you collect and cluster together, and that's called affinity diagramming. And that's used to really understand the domain in which you're trying to create your technology in order to better address the needs of that area. So these are some of the things that we do in our program that are good, I think, techniques for any educational technology development, and maybe even more generally in technology development. I mentioned about learning science, and that's one of the things that I think is very important in the EdTech area, and one of the things I wanted to advocate in this talk. It's sort of best in class is what you're trying to go for. So what do we know about how people learn and what comes from learning science that we can bring to the actual application area of educational technology? And some of the most prominent approaches, and these are all approaches that have been researched extensively, and many of these have been brought into products, and they're very important. So, for instance, learning from worked examples. We know most of us, from our own education before technology, if you had, let's say, a math book and you enter a new chapter, well, the approach for how to solve problems, let's say in calculus or something, there would be examples shown to you in the textbook, and you follow through the example to help you learn. And that's been tried and true, and has been tested quite a bit in learning science and even in a technology area, and even things where most of the examples provided to a subject, but then some aspects of it are left undone so that you're given kind of this context of how to solve a problem, and then you are tasked with finishing it. And there's been a lot of research that's shown the value of this, especially for people who are new to an area. So for what we would call novice students. Self-explanation, prompted self-explanation is another area that's really valuable, something to consider to put into technology. And this is where you have problems that or whatever the context of your area, where you present things for students to tackle, and then after they've solved a problem or tackled some kind of an issue, learned, let's say, new phrases and new words in a language, that you then prompt them to explain what they've learned. And there's lots and lots of evidence that shows that that's a very robust technique for reinforcing learning. Others that are really common, especially in ed tech, are immediate and customized hints and feedback. We know that, if students are struggling, it's a good idea to give them some hints or help. And there's lots of evidence that supports that. It's also important to give feedback when they do things that are incorrect. Metacognitive support is an area where metacognition is sort of knowing about learning. So the idea is that you have a kind of a plan about learning, and it's really important. The best learners definitely have kind of the best metacognitive skills. And that means that they're good at planning their learning, they're good at executing it, and they're good at reflecting on it afterwards. So there's been lots of studies that have shown that students who have good metacognition skills are really good learners. So it's important to try to enforce that kind of knowledge to students that can then persist to not just the area where you're presenting information to them currently, but hopefully it'll persist into other areas. We at CMU have a course called E-Learning Principles, and that is a course that focuses on the set of principles that Richard Mayer, who's a prominent educational psychologist, has identified as really important for how to develop educational technology. And he's done studies, he and his colleagues have done studies that have shown the benefits of these. And they're actually fairly micro principles. So for instance, there's one called the contiguity principle, where he studied how when you present things on a screen, and let's say there's a graphic and there's text, that if you separate the text and the graphics, you're going to have less learning than if you put the text together with the graphics. Some of these principles, you might even say that one is something that should be almost intuitive, but that's an important but this is a really important area, and I strongly advocate, if you're building educational technology, that you have at least awareness of these principles, because they've been well tested in terms of how well they support learners. Okay, so the best of learning science principles should be brought into play. Now I'm going to talk a little bit about design and development, both what we advocate and what I think is kind of the industry standard. Hopefully, many of you who have already started to develop products are aware of these design and development approaches, but many of you may not be. So we advocate for lean and lean development, design and development, and creating MVPs by lean product design. This originated from Toyota originally, and it focuses on maximizing value while minimizing waste. And it also emphasizes iterative development and customer feedback. And that third bullet is probably the most important because you do iterative development, meaning that you don't do a lot of development, but just enough that you can get customer feedback. And then you can either find out that you're on the right path and you continue with that, or you may need to pivot if the feedback tells you that what you're creating is not going to match up well with your market area. And to do this, you create what's called a minimum viable product or an MVP. And least effort, you can see I italicized that. So it's basically the least effort to develop a product that can then be tested with real users. So the idea is that you create some small piece of what it is that you are intending to develop, and then you validate that with users, or find out that this idea is not a good one and that you need to pivot to something else. So key principles of lean are determining what users truly need. Okay, so that's one of the things you're going to find out when you apply lean. It streamlines processes to deliver this value in a very efficient way. This iterative process leads to flow and smooth progression in development. And it also has this kind of pull feature to it in that you're getting actual user demand and actual user feedback. And finally, you have continuous improvement. Again, the iterative design and development leads to that. Okay, so, oops, I'm sorry, went the wrong way here with my slides. So it's kind of hard. This is one of the things that our students struggle with the most with an MVP is how to scope one out. Kind of the older style approach called the waterfall approach was that you'd kind of scope out all these, design items that you'd create in advance, and then you'd, develop it. But the idea here is you want to be, small bite sizes as you're moving along. So you want to focus on sort of the right criteria, the most, let's say biggest bang for the buck aspects of the area that you're working in, and prioritize features in that area, and then just implement a small number of those features, test it out with customers or clients, and see if you're on the right track or not. Okay, so that's a little bit about design and development that I advocate and that we teach in our metals program. What I'd like to do now is talk a little bit, give you some examples of EdTech companies and projects, some of which, actually the latter half of what I'll talk about, are projects that were actually part of our metals capstone. But the first couple I'm going to talk about are actually EdTech companies that came from CMU, using a lot of what I've already talked about today and have had some success. The first one is what I would call a big success story, and this is a company called Carnegie Learning, which is a spinoff from CMU, was founded over 25 years ago by several CMU professors. I think Ken might have given a talk in this series before, and maybe some of you were at that talk. So Ken was one of the founders, along with Al Corbett, Vincent Laban, and John Anderson, and also a CMU PhD grad, Steve Ritter, who is still with the company as the chief scientist of the company. And that's pretty critical, and I'll talk about that in the next slide, that Steve is one of the founders. Basically, what this company was focused on is intelligent tutors using AI for middle and high school mathematics. It's expanded that now, but that's what it started on. And it originally developed what were called cognitive tutors for that marketplace, the middle and high school mathematics. Its most recent product is called Mathia, and it has a pretty large footprint across the United States and Canada. So it's in many, many schools, K-12 schools across the United States. I spoke with Steve because I wanted to find out what he thought were the secret sauce and the key ingredients of Carnegie Learning success. And that is that one of the things that they did is they focused on the core curriculum, so the existing core curriculum in the United States. And what they did is they didn't produce just the technology, but they also provided text materials, and they still do this, text materials and implementation support with the product. So in other words, instead of trying to take the schools outside of their current process, basically they join in with that process and in fact even provide extra materials for the existing process. And that was one of the keys to their success. They also accept responsibility for student outcomes. So they've, heard how their students do that use cognitive tutors. They've done large scale studies of that, and they've shown that students who use the cognitive tutors learn better than those who don't, or who don't use the cognitive tutors. Another important one, and this is where I come back to Steve Ritter, is that they have a willingness and desire to collaborate with university researchers to improve their products. I know this because I've collaborated with Steve on products, and so have some of my colleagues at Carnegie Mellon. So instead of just spinning out a company and working completely separate, they've been very open to what's happening in the research world of academia so that they can then dovetail that back into their product. And that's been one of their underpinnings for their entire existence. And a lot of credit goes to Steve Ritter for that, because he had this Carnegie Mellon connections, and he also had kind of the research mind and understanding of learning science that he kept that connection. So those are the kind of the secret sauce of Carnegie Learning. Another what I call emerging success story is a company called Narilla. This was founded by a former PhD graduate, Nezra Yanir, and two professors. Again, Ken was involved with this startup, and Scott Hudson. And what this is it's a mixed reality AI-based game that bridges the physical and virtual world. So you can see here in this this picture here, and by the way, it's for 4 to 8-year-olds, is they look at a screen, but they're actually, you can see, if you look between, right in the middle of the screen, you can see there's blocks. And there's a specialized AI computer vision algorithm that can see what they're doing with the blocks. They're being prompted on the screen what to do, and they are creating like towers and different things with the blocks. At the same time, this computer vision algorithm is looking at them, and it's adapting to what they're doing and providing personalized feedback. And there's approximately 40 installations of this of the Narilla product between the United States and Europe. So I talked with Nezra as well to find out what she thinks is the secret sauce of success of her company. And that is that she thinks the game provides this interactivity and hands-on experimentation. She's found that it's very intuitive for children, educators, and caregivers. It doesn't take a lot of startup. It's one of the things to be aware of is, having a technology that takes a lot of training to get started on it. With Narilla, kids can kind of jump right in. In fact, it's installed in science centers, and kids can just come right up, start playing it, and kind of almost immediately understand what's going on. The other part of the secret sauce that Nezra told me is that there's this non-player character. It's this gorilla. Again, you can see in the photograph there, if you look on the left side of the photograph, there's this little gorilla character which guides children to understand the reasoning behind things. Okay, so those are the two things that she thinks are the biggest advantages of her product. So now I'm going to talk a little bit, and this is kind of the completion of the formal part of the talk, and we'll have time then for questions. Here are some of the example projects that I've been an instructor for the metals course, and I think there's pretty good variety here. So it gives you some idea of what kinds of products and projects our students do. So the first one was for Houghton, Mifflin, and Harcourt, also called HMH. And they're a former book publisher, but they're now in the EdTech business. So, and this happened a lot with book publishers in the United States, is once educational technology became pretty prominent, And they weren't just able to just sell textbooks. They had to have something more than that. They kind of segue into the ed tech business. I think most of the book publishers have done that. This is targeted at users in the K-12 space. And the students on this team developed a language learning app. And what they did is they created this immersive environment in a video where the video would stop and ask them questions. So they actually filmed, I believe it was buying products in a Mexican grocery store. So the kids were learning Spanish. And they would interactively learn language through stop and start of the video and interacting with the video. And it would also allow the students to request help and support. So that's one example. Another team did work for Western Governors University. That's an online university in the United States, a nonprofit university. And it targets older learners. So unlike the first example that was for K-12, here we're talking about older learners. So they're mostly people who are working part-time or working full-time, and they're going to school part-time. Okay, and they developed a mobile app to help those students learn on the run, quote unquote, when they have time and opportunity. So like, let's say they're on the bus or, it's late at night and they're about to go to bed. So they have a little bit of time. So they get on their mobile app and they learn. And they particularly focused on older students with limited time. And it could also be applied to situations where students are mostly remote. Okay. Another example, Varsity Tutors. This is a company that matches and provides human tutoring to students. And it targets the K-12 space again. And the application was to develop this analytics tool that used LLMs, the large language models, the newest AI that's out now, to analyze tutoring transcripts. So the transcripts between the human tutor and the student are recorded, and they wanted to have a way to analyze what went on in those tutorial sessions to provide a way to reach higher quality tutoring. So basically what the app did was summarize student experiences in tutoring sessions. Turn the Bus. This is an interesting organization. It's a company in India. It's a nonprofit organization that's dedicated to improving education for underserved populations. They specifically, at least on this project, I don't think the organization as a whole does this, but at least in this particular case, they targeted 12th grade students. This is a mobile app, and it would help students learn physics through these simulations. And the simulations would have adaptive hints and ways to sort of explore the physics domain. So another application for product development. Just a couple more here, and then we'll be open for questions. This project was for the company Scholastic, and they're the world's largest publisher. Again, this is an organization that published books, but they're also now in the ed tech space. This targeted K-6 students, and what the team did is build a reading literacy game that would use gamified approaches on this reading platform and would personalize the content to help students learn. And then finally, this was a really different and unusual application. This was the National Neuroscience Curriculum Initiative, or NNCI, and this client is a collaborative institute between educators and neuroscientists. And the target population here are medical students, so older students. The application was to help to destigmatize attitudes towards mental illness. I think, as I recall, the main clients on this project recognized that many doctors weren't very, let's say, empathetic and understanding of mental illnesses. So what they wanted to do is they wanted to incorporate into their curriculum ways to have in their elective medical school courses to help those doctors in training to improve their attitudes towards mental illness. And they use neuroscience as the basis for course improvements. So I tried to pick projects that were kind of across a range of different student levels, different marketplaces, to give you an idea. Over the 10 years that I've been an instructor for the course, I'm going to estimate that there's been about 50 to 60 clients that we've worked with, and 50 to 60 projects that we've worked with over that time period. So I just wanted to give you a taste of some of these projects that I've overseen as an instructor in the Metals capstone course. And with that, I I have no further slides to present, so I'm open now for any questions.